more of you in the community if this is your first time with us. How many of you is this your first time? Oh, that's great. Another 10%. Every week I ask that question, and it seems the crowd continues to grow, so that's fantastic. If you're joining us from the internet, thank you very much. I hear that we might have gotten stampeded by the CycloneDX Slack, so if you're here from the CycloneDX Slack, welcome. Some of the announcements that came up here were call for proposals. There is a conference coming up in Barcelona. Call for proposals closing, I think, in May. If anybody can correct me on that, go ahead. We also here at OWASP Ottawa are always looking for more folks who want to share their knowledge with the community. So if you have a talk that you've given before, if you have a talk that you'd like to give for the first time, we'd love to have you submit that. Again, you can get to submission links and everything else for the community at owasp.org/Ottawa. Garth, are we ready to go? Am I forgetting anything else? All right, I will keep vamping. I noticed that Greg brought a Tim Hortons. Just one. I heard that the roll up the rim ends soon, so it's not quite the same as when you used to actually get to roll up the rim. Okay, so we've got a fantastic speaker here with us this evening, alumni speaker, and Pavel Shukman has more than 20 years experience in this industry, in this space, coming all the way from work building teams, finding people, pulling people together and growing teams, all the way to growing companies in the space and growing teams in those companies. And so we are very lucky to have Pavel's insights with us today on CycloneDX and some of the problems that you can or maybe cannot solve with that suite of tools. Who's heard of the OWASP CycloneDX project? That's more than I thought. And the reality is that I'm engaged in OWASP, and I continue to be amazed at some of the projects that come out of OWASP. So CycloneDX, I will admit, I have not engaged it with myself, and the result of this talk has been, I've learned a little bit more already, and I'm looking forward to learning a little bit more from Pavel here today. I think I'm just gonna hand it over to you if Garth tells me I'm okay to do that.
Thank you very much.
Hey, we got the thumbs up. All right, ladies and gentlemen, Pavel.
Do you hear me on the microphone? Awesome. I think we have slides on YouTube now, so everything seems cool. Yeah. No, I see it on mine, so I think we're good. I just checked. But we don't have them here. Yeah, so Garth, if you could.
On it.
Oh, okay, awesome.
I had to change it back.
Okay. Yeah, so we're waiting a little bit until slides appear here, and then I can start. So while we're waiting, because I couldn't actually hear the audience, let's try show of hands one more time. So can please, people who are familiar with SBOMs, before they read the title of this, it's almost everybody, cool. People who feel they're experts in SBOMs. I'm just trying to gauge, you know, the audience, like how. Okay, this is off. How familiar? Okay, so this will be the topic of what I'm going to talk about. So, who knows what xBOMs are? Can you raise your hand? Okay, so a couple of experts in here. Okay, and I'll describe what they are a little bit later. Okay, So this is very quickly about myself. I founded a company called Reliza startup where I still work in 2019. And CycloneDX is OWASP project, and actually we'll discuss a lot of OWASP activities today, is what actually was very useful for what we were doing at the time, and I'll describe why. And I became an early adopter of CycloneDX, which appeared in 2018. Right now, we're listed as a vendor supporting CycloneDX, and we're building SBOM tooling. And I like to travel myself, so this is a picture of me in Spain. I don't think you can see it well, but yeah, I like traveling a lot. So that's about me. Starting on the SBOMs, let's kind of look at the big picture. So big picture, 10,000 feet view. So I wrote all those circles that you probably heard about. So static security testing, and then this is not a real abbreviation, but it's a supply chain security. I abbreviated that because otherwise it would be too big. And then software composition analysis, that topic that came frequently in security. So I just tried to kind of put those things on their places, okay? So SBOM, a lot of people say, okay, we have software composition analysis, so we like break the software into pieces and we do scans. The problem is supply chain security is much more than that, and we'll describe a little bit why. So now I need to scare you a little bit, right? It's a security meetup. So it comes, there has to be like part where everybody needs to get scared, like what happens if things go wrong? So is there anybody who is not familiar with one of these? There is no shame. One of these incidents, yeah, so there are actually more, but those, the first is big one, NotPetya virus, which appeared in 2017. So what was it? There was accounting software in Ukraine, which was used by, I think, like order of 100,000 organizations. And its supply chain was infiltrated by Russian hackers at the time, which create massive blast radius. That was maybe one of the first very large supply chain attacks. The second one is SolarWinds, which is maybe until now not fully mitigated. Nobody knows. The fun part is SolarWinds is IT security company. I mean, it's not the only one. It's actually funny when security tools become the medium of attacks. That's interesting. And so SolarWinds attack is, again, where, so SolarWinds itself was a dependency for a lot of large-scale organizations. And it was infiltrated. Its supply chain, we don't know exact mechanism, how it happened. But then all the companies who were using SolarWinds as their dependency, and there were like really, really large organizations, were compromised. The third one is like classic example. Everybody in the field talks about it. It's not like, so those two attacks, they have malice. They were performed with malice. Log4j is a bug vulnerability that existed in software and allowed remote code execution. And we don't think, basically, we don't know, but we don't think that there is malice. The problem is that Log4j is such a popular library that it was used like everywhere across the board. So if you were in the industry at the time, what was happening is people were scrambling to figure out whether they're using Log4j, whether they're using affected versions, where are they using it, are they secure, are they compromised? And it was, people spent insane amount of time trying to gather this information. This appeared to be very hard. So these two events, 2 and 3, were actually the main catalyst for popularity of SBOMs, which they are pretty popular now. And for Discord, there were more attacks. I just took this one because it's recent. And also, this particular attack, it was pretty sophisticated. So how people worked, they compromised a lot of little Python packages, created packages that were looking like some known packages, and made unaware people use them. So essentially, what you need in this attacks is you need to inject some odd piece in the supply chain system, and that's how you break things. So you probably saw the word transparency in the beginning of this presentation. So essentially, transparency is the answer to supply chain security. The point is that we need to know exactly what our software consists from. It doesn't mean automatically that we are like 100% secure and everything is, the world is bright. But this gives us degree of confidence in the tools that we're using, in the things that we're doing. And so essentially, transparency is the end goal of all this exercise with security. Okay. So now this is like the most important slide of today. Yeah, it will continue.
Is that a CD?
Yeah, that's a CD. Yeah. For people who know what this is, or DVD, I don't know. Yeah, yeah. So the most important thing that, like, what is SBOM and software metadata as a concept? So before we had like a block of software that we were giving to people, like a package. In this case, it's a CD or DVD. Like DVD is larger. And now we start splitting it in parts. So first part is source code, binary, whatever it is. You can actually split it to source code and binary. And the second part is metadata. So again, this is the most important slide because this is the concept behind SBOMs, all the transparency research and everything. Because before, and let's say if we're just talking like traditional software composition analysis, then we're only talking about like this hub. Like the new thing is that we now take some metadata from software and then operate on this metadata. If this is not very clear, then ask me questions, because this is really important.
Okay, what metadata are you taking? Or is that your next slide?
So no, it will be in the slides, but here metadata can be a software vendor, software version, software name, which name is a big thing because there'll be like a separate slide, software identity. Software can have hashes. So let's say if you have a file or package, you can take SHA-256 hash on that, establish integrity. You can sign it digitally. So all those things may be part of software metadata. By the way, your question about metadata is very valid because it's a subject of what a lot of regulators are writing. And they're writing a lot of different things. And there was a recent talk by Salve Nilsson at FOSDEM, a very good one. I included it in the references to this video. So it's not actually set in stone at the moment what this metadata is. But essentially, metadata is a lot of things about software. Now, talking about SBOMs, metadata specifically is a set of dependencies, like what the software consists of, maybe how it was built, how it was produced, so all those things. So, oh, too early. So my question here is, you can ask more questions, but now my question to you, why this matters, basically? Go ahead.
It's like if you had a piece of, like, you have food in your cupboard and you didn't know.
Sorry, can you speak a little loud?
Just if you had food in your cupboard and you didn't know what was in the ingredients list, it's important to know what goes into the software. That's the way, like, in case, like you said, the supply chain attacks, that one of the dependencies being problem, you know, okay, I actually have the software in the list in like my stack. So I can address that.
Yeah, awesome. So yeah, so I'll just summarize. So the point was that now we know, if we know like the dependencies of the software, if the attack happened or something happened like log4j 0 day, then it's much easier to search on a set of metadata than to rescan all our software, which we maybe don't even know where it is. Okay, sounds good? You wanted to add? No, like same point?
No, I was just going to expand on the food analogy.
Food analogy? Okay, if you want, go ahead. So.
Okay. When I go shopping for food, I have to check what kind of salt it uses. Salt. Wrong. Sometimes they put in sea salt. What's wrong with sea salt? Sea salt has bits of fish shit in it. Fish stuffs, fish skeletons, and my daughter-in-law is allergic to the things that wind up in sea salt.
Okay.
And almost all her allergies can kill her.
Yeah, it's a really good point. Yeah, so for those on YouTube, the analogy was about food, and we need to check list of ingredients before buying in case somebody has an allergy to one of them. I have allergies to certain things as well. Yeah, we kind of want to know it before buying. And again, it is a little bit weird to buy food first and then taste it and then figure out, do you have allergy or not? You probably prefer to know it from the list of ingredients beforehand. Great point. More ideas?
Just one question, just specific to this slide.
Sure.
The metadata you're referring to in this particular case is unique and specifically defined with the binary on the left.
Right.
Okay.
Yes. So we split the thing on the top to two things. I mean, split is not really correct because it still has, but it has this metadata part. In this case, I don't know if you see it well in here, but this is a beginning of the CycloneDX actually BOM manifest, what this text is. But yeah, I see the resolution, yeah. I'll try to make it bigger later, so we'll see. There are a couple of things I want to present later. So I'll just expand, so a few more things here. So one is, this is like second most important slide. So security scanning is a moving target. This is what a lot of, in a lot of conversations gets missed because you do scan today and it's clean. No vulnerabilities, no, like everything's perfect. And then you do scan a month from now and maybe it won't be clean. So on the same software, over time, you get more vulnerability hits because there are vulnerabilities that are not known at this moment, but they exist and they get reported later. And this is this is very obvious I think. But in a lot of conversation, it gets missed. And what's happening is people ship something to production, and it was perfect at the time, like it was perfectly clean and fine. And then it sits there and sits there and sits there, and they think it's still perfect, but it's not. And that's a problem. And when you do this kind of metadata split, then it's much easier to do this continuous risk cancel on metadata. And one tool, OWASP Dependency-Track, that I'm going to show a bit later, it actually does that. So it ingests your metadata, and then it continuously rescans anything that's wrong. Yeah, so here I wrote like, I had more time than you to think about it. So here I wrote like two things. So one, what I mentioned just now is rescans moving target. Much easier to do on structured metadata than trying to rescan like every piece of software you have anywhere. Data querying. So again, log4j issue. If you have a proper, it kind of doesn't exist yet, but it's getting there. Proper tool for SBOMs. You enter log4j, gives you right away every piece of software where log4j is. You don't spend like a lot. So the problem is not even with spending a lot of time trying to figure out where log4j is. The problem is while you're looking for, if you have it, then you're vulnerable. If you're able to answer this question very quickly, then you're able to, like your response time on any zero-day issue is much faster. Then there is exchange and distribution. This is more like from the food store analogy. So when you say you're a vendor or you're a buyer, it doesn't matter, or you just want to use some open source product, then right away you can look what's inside this product. Which, again, with proper tooling, which is partly exists, partly coming, this becomes much easier. Pre-build analysis, that's, again, related to the food store analogy, is you can, so if you see, for example, right away that a certain package doesn't fit your policies, then you reject it right away, don't spend time on it. And then we'll discuss this later. There are a lot of compliance things that are coming. Some of them are there, some of them are coming. Any questions here? Okay, so we went through all the most important slides. Just for people who are in a rush or anything, that's so you know. Down below, there'll be expansion of all those concepts and things. Okay, so there are two main standards. There are also suite tags, but yeah, this is like, I don't know if anybody using that. So SPDX, that's like an old one, exists since 2011. CycloneDX exists since 2018. I think I already mentioned that. And CycloneDX, for, I don't remember which year, but for the last several years, it's OWASP standard. So it's managed by OWASP Foundation. Personally, not because we're at OWASP meetup or anything, but personally, I highly prefer and recommend using CycloneDX because I believe they made a lot of very good choices in the beginning. And also, I don't feel there is a need for two standards in the space. Also, OWASP Foundation is very respectable. So it's much easier for everyone if everybody would just convert, like in my opinion, around one standard. Sure.
I'm wondering if there are other standards that are like popular, or are those the main?
You're asking if there are other standards that are popular? So the ones that people really work with are CycloneDX and SPDX. There is also what's called suite tags. I don't think anybody works with it. So realistically, only these two standards they have some traction. Okay, so now, so this thing actually popped up before, but it's one of the biggest problems when we're talking about software metadata, like managing these things, is how do we identify software? It sounds very simple, right? I mean, if you have like a product in a supermarket, it has like usually like a barcode with some numbers. If you have a book, you know, it has like ISBN number. Like every book pretty much anywhere in the world has this ISBN number. So you identify it by number. Now, how you identify software? Huh?
Brand product with version.
Shahash? So how do you manage it? So brand, product, and version is cool, but like I give you an example. You know, there are things, let's say curl, right? So curl can be a Debian package, standalone binary, YAM package, and common like exe file for Windows. It's you have an idea how to? So you're suggesting to identify by master Git repository, but then do you think we're like, first of all, it already not the case that everybody is using GitHub or GitLab, and then do you think we're giving too much power to GitHub? I mean, it already has too much power, but is it a good thing? Yes, I agree with you. The problem is exactly how do you make it distributable on one hand. So how do you make the system of identification distributable so we wouldn't have one entity which has all the power? And at the same time, you're still able to actually name things the same way. That's a hard problem. I mean, it's really a really hard problem. So I won't kind of. So there was a US government mainly like working on standard called CPE, which is super difficult. I don't know it, but it existed for, I don't know if anybody heard about it. It exists. So they make like a dictionaries of CPE names. But this package URL, this is another OWASP project, which is very cool and which aims to solve this problem of naming things. So it's not final. So it's going to become a standard under ECMA. And it's not final, but right now what they have looks like something like this. Can you see the screen actually? And this is a sample for curl. So interesting part is they have, so they mentioned that it's Debian package manager. I'll share the slides, by the way, so don't worry. I mean, you'll have the slides. So, and then there is curl. So if it's curl but not for Debian, you would have like another type here. And then you see you have version, and then qualifiers, which in this case are like architecture and distribution. Distribution matters because it's not like not every Debian maybe supports this. People guys on the back, do you see it? Okay, cool. Because I can read it if needed. So now, again, I'm not like part of this group or anything. I'll just give some thoughts on this, like problems that are good parts and things that are still there. So good part is you can already name things pretty well. Problem is it's unlikely you'll ever be able to do full string matches on this. But you likely will be able to do searches with a certain degree of confidence. So basically, you know that name is curl. So if you do name curl, then you're supposed to get curls for like every architecture. So point being, this doesn't like solve the problem in ideal way, but it gives you a structured way to search for these things, which, given the current state of the things, is kind of good enough. And current state of the things is people doing fuzzy text searches, hoping that they'll find something. At least this gives a relatively clear structure. If there are any questions here, we can discuss, or otherwise we'll move on. Okay, cool.
What's the versioning format? 7.50.3-1. What is it? Why dash isn't there?
That's a standard semver. So we'll discuss versioning later, but this is, in this case, this is standard semantic versioning. Dash, I don't remember exactly how this element's called. I think it's called either metadata or qualifier in semver standard. I don't remember exactly by name, but in semver you have major, minor, patch version. Then you can have minus, let's call it metadata. I don't remember exactly, and no, minus qualifier, I think it's called, and then plus metadata. So that, but in this case, this is not like vendor or curl maintainer provided version. So this is version of curl application, and the Purl standard, they only treat it as a string. Okay. Okay, so now let's talk about CycloneDX a little bit. So we spoke about the version identities. So I believe that one of the very cool parts in CycloneDX, because CycloneDX has this concept of components. So when you describe structure of software piece in CycloneDX, it has a list of components, and everything in CycloneDX is a component. So, and in this case, like I have this is part of a real CycloneDX BOM file, and you see it has component, and here it has Purl that we just discussed. So Purl is essentially identity of this component. So if you know nothing else, then potentially Purl should tell you what it is. So there are other things. There are like name, client. This is Apollo GraphQL client, and the name you see is only client, which is like hard to like group. This is fine. This gives you like a vendor, but Purl sort of gives you everything. So this is how identities fit in this BOM, bill of material files. Okay, so now there was question about versions. So versions are hard because there are different standards. There is semver or semantic versioning, which is most popular and best documented standard. Then there are multiple flavors of calver, what's called calendar versioning. So generally speaking, versioning is a subject of like, and I did, I think, a talk on that at some point. Important thing that a lot of versions are different. And if you're talking Debian packages, they wrap versions in versions, which is like, so if we take like curl as a Debian package, it has version of curl application, and it has version of this whole thing in Debian package manager. So if you do apt install on curl, you will see like 2 versions, which I know it's super confusing. The point is, versions are hard to compare between each other. You frequently don't even know what they mean, as there was question for curl specifically for each single component. And how do we deal with that? Okay. So there is another OWASP project, which is like part of Purl, which is called Verse. Haven't heard about it, Gard? No? No? Okay, cool. Something new. Something new. Okay.
He's counting. I'm wildly guessing. I'm guessing high, I think.
So Verse is made like, they made it actually, the problem they're solving a lot is version ranges. So the question is, you need to say that, okay, my, for example, library is compatible with another library of certain version range. So then question is, how do you express the range? So they added, in a smart way, this thing, version scheme, which in their case is usually refers to a certain package manager. In this case, NPM. And NPM is using their own flavor of semantic versioning, if that matters. But the point is that they name the scheme in here, and then they have special rules to say that either version 1, 2, 3, or it has to be between essentially those 2 versions. So these are special rules how you explain this versioning ranges, which is very neat, in my opinion. Yeah. Say it again.
Can you put that, like, the version thing into like English? Because I don't understand what it's actually saying. NPM, we're going to use NPM.
NPM is a okay. The question is, what's NPM? So NPM is a,
not what NPM is. I'm asking, given we're using NPM like version 1.2.3.
yes.
Is that saying we're going to use whatever package greater or equal to 2 or less than 5? Because that makes no sense.
This says, no, the idea is that you have, so imagine you have a software that depends on some library, but not every version of the library is good. And you want to express a range of versions of the library that are good, that will work with your software. So this gives you range. So what this records mean, you need a version. So, oh, sorry. Wrong button. So what this means is a version of library 1.2.3 is compatible, as well as versions between 2.0.0 and less than 5. This is what this says. And significance of this is before this convention, and it's not even like fully established yet, it was actually very hard to do it across the board, because not every package would have this versioning. Like a lot of them would be different. Okay, now we'll talk about xBOM. So I know there were few people who knew what xBOM is, so not a big surprise. So the word which became very popular is SBOM, which means software bill of materials. But then the question became, why does it have to be software only? And that's how the term xBOM was born, because there is no point to constrain us with software. And that is also a big distinction, like why CycloneDX is better than SPDX, because they realized this property from day one, pretty much. So they didn't make it software-centric. So all those things are kind of xBOMs. So this is for SAS, not very interesting. CryptoBOM. CryptoBOM is very interesting. It lists cryptographic assets, like, let's say, algorithms that you use in your application. So if you have it properly in metadata, you can, for example, assess whether your algorithms are quantum safe or not, things like that. Then hardware bill of materials. Why not? And like manufacturers, actually, in traditional manufacturing, they have pretty good sense of bill of materials. However, now we have a lot of, in the tech world, actually everywhere, you have software plus hardware. And this is very hard to express. Everybody does it their own way, frequently not in a good way. Like you want to know, let's say you have a medical device, you want to know, will it, like what firmware does it need? Or are you on the latest firmware or not? Frequently, this becomes a difficult problem. With the HBOM, if you combine it with SBOM, then it becomes more manageable. Machine learning BOM, very cool. So again, a lot of AI tooling. AI is like booming right now, everybody knows. But attacks on AI, probably a lot of discussion. I know there was a meetup here, RightGuard, I saw a couple months ago about like how you can compromise the machine learning model. So this should give you like a better sense what things are coming from. So OWASP is what we actually use a lot at Reliza. This is operational bill of materials. It describes how things should be organized in the environment. So the cool part about bill of materials is you can use it as a document based on which you deploy software. So for example, I'm a vendor. I can give you a manifest, and you know exactly what versions of each component you need, rather than trying to pick like by latest tag or some other shenanigans. Manufacturing BOM. So VDR and VEX, those are big on vulnerabilities. So this is like a list of all vulnerabilities as this one. And VEX is like a negative. So essentially, if you're a vendor and you want to say that you do not have log4j related vulnerabilities, you would make a VEX document with that. Then attestations are really, really big right now. They are required, we'll discuss about it. So this stands for attestation. So attestations are any statements about your software. Like that it was produced in a safe and secure environment, no pets were harmed, things like that. And yeah, BOM link is how you reference bombs from other bombs. So we talked about regulations. Again, I refer you to like this talk from Solvin Nilsson, but those are a bunch of, I know security people, they like abbreviations. So those are a bunch of regulatory documents that exist. So in Canada, BOM is mentioned in this document on secure practices. It's recommendation only though. In European Union, they have CRA, which should become enforced in 2 or 3 years. And basically, they will require pretty much every vendor to prepare bills of materials and attestations with their software. In US, I put it like it's mostly regulated, but hard to say what's going to happen now in US. but those are the documents that say that every vendor to US government need to provide certain SBOMs. So all these are Biden's era executive orders and CISA document based on those orders. So in India, they also have a document describing SBOM. This is all being actively developed, and like we don't know where it goes in terms of. We think that regulatory pressure will increase over time, especially regarding European Union. They already announced it. Okay, now I'll quickly. So we have about 10 minutes. So that's a very short demo. I have time. Okay, perfect. Okay, so this is like our open source project, which is actually a simple catalog of bills of materials. So what I'm going to do here,
Is that a public repo?
it is, yeah, don't worry. Yeah, go ahead, but the link is not very relevant, and the link will be like on the slide, I think, in the last slide. Okay. So this public repository is, you see the screen, right? Do you like this? The font is it? Okay, unfortunately, I don't know how to remove. Okay, so
ES1 equals
Pavel Shukman.
ES1 equals $sign.
PS $sign. I don't understand.
Type in ES1 equals.
Just type it.
Sorry.
How we remove this one?
Oh, okay, I see. Thank you very much. It's Windows. Maybe it doesn't work. Yeah, maybe it doesn't work like this. It's okay. We'll be very quick. So basically, it's fine. We won't. Yeah, let's not spend time on this. So
What happens when you put a bunch of computer people in the room?
yeah. So let's focus on yeah. So the point is, this is a Node.js project, and I'll just use different tools to create both CycloneDX tools to create bill of materials. So I have commands like pre-written. Hope you excuse me. So first called CycloneDX npm. It's very fast. You see it? I mean, it's not a huge project, but still. And the second tool is called CDXGen. Now I just want to show you what we get here. So this is made with CycloneDX npm. So again, you see like all the components here. So components go here. These are all our dependencies. And then this dependency section essentially lists relationships between different components. And then with another tool, it's kind of same thing. But an interesting point here is this does not have licensing information. So this has licenses, and this does not. And the point I want to make that, first of all, SBOM creation from software is mostly a solved problem. Like there are a lot of very cool tools that do it very quickly. Like you see, it's no time. But the tools are not made equal. And sometimes, given this output, you need still to do some tinkering with some weird characters or stuff like that. This is what we see in reality. So you need to do some exploratory work in terms of what works for your code base. And now, I mean, hard to imagine that anybody would really work with this JSON as is. So this is a OWASP tool, fully open source, which is called Dependency-Track. And I just want to show you how we import this project. So I'll do Rebom front end, demo, version, doesn't matter, and I don't remember it. And I say application, so I create project. So here is my project. And here I want to upload my bill of materials. I'll take the one with licenses, which is this one, because it's better. Up. Of course, it didn't work. Oh, it's a demo. Yeah, it has to fail. I have one that I imported before. Okay, maybe, okay, I'll do one try here. If not, I'll show you the one I imported before. Huh? No, it shouldn't. Okay, that's fine. I have one from before. I hope it works. It's the same project. I mean, I did it just before, like coming here, so that one worked. So you see, and usually this one works too, but I don't know what happened. Probably demo happened. So here you have this same SBOM, but presented like nicer with components, versions, and then you see this marked as outdated component. Like it tells me that there is a newer one. There is like a nice dependency graph, which shows level, like where it sits in the hierarchy. And then it does some vulnerability analysis. So here it lists certain CVEs assigned to those components. And you can add like licensing policies, operational policies, stuff like this on top of these things. So I don't know what went wrong with this other file, but maybe, yeah, I don't know, I won't speculate. Try to figure out later. But this is essentially a tool that makes it more manageable, and you can play with it. It's fully like open source. You can host it on your own. So now the problem with this, and they're trying to solve it, but it still exists, is when you have a lot of projects here, it becomes a little bit messy, because every software release becomes a project. And you end up with a huge number of projects, which is hard to deal with. And for that, let's go back here. Yeah, a little bit of a mess we have. And so for that, there are two OWASP initiatives that exist. First is common lifecycle enumeration, which aims to list. So on the left, I put stages related to SBOMs or xBOMs. So xBOMs may be created on the design of your application, on the build, post-build, etc. And on the right, those are things related to your product. And product, these are interesting things that can happen. Also speaking about the identity. The name may change and then it becomes suddenly very difficult to identify. And then there are those version events. So this is one thing that exists to organize this mess. And the other thing is Transparency Exchange API. This project is in the very early days, but the aim is to build a unified open API spec. How any vendor can upload, download SBOMs with the same open API spec. So it would be simple for everybody to do it, given that regulators are going to require, at least in Europe, in 2-3 years, they will require pretty much everybody to do it. So they want to make the spec to make it kind of more manageable. Okay, this is a set of links. And there may be more, but yeah. And I'll share the slides so you can explore them later. And that's it.
Pavel, thank you so much. I learned a lot. I was also really excited to see, even in live demo mode, getting all the way into Dependency-Track and actually like seeing the magic happen. Tell us a little bit about what, like you kind of quickly walked through the stack that you're kind of using to create the SBOM and then to import it. In this open source world, if we had a project we wanted to go home tonight and get started, where would we go to get started? Does that question make sense?
Yeah, absolutely. So I showed on a demo, which partially went well and partially didn't. I showed commands from command line to build SBOMs. So normally, you put it in your continuous integration. Let's say GitHub Actions, Jenkins, Azure DevOps. I don't know what, like, I actually played with a lot of those. But you put it in there, and then you can actually upload stuff directly to Dependency-Track from your CI. Now, it's actually not announced, but we already published on GitHub open source community edition of our BOM repository that you can use as a wrapper around Dependency-Track. So what it's doing, it's going to implement this Transparency Exchange API thing, and it's organizing all your project releases and then connects to Dependency-Track to do parsing analysis and all that. But the procedure is the same. You put the thing in your CI, then you put some API token to your tool, and it uploads on the fly. This way, there is no extra time required from, again, even if you're not using it for anything, you're not, for example, looking at vulnerabilities or you think the scans are wrong, at the very least, what you get, if you have another log4j 0-day, you go to Dependency-Track, you do a search, you'll have some information like where it may happen in your stack.
You've got an ingredients list.
Yes. So even if you never look or care about it, for various reasons, it already gives you additional benefit in case of emergency. Like you have another extra tool.
And how much, tools, that's more surface area. Tell me a little bit about, like what's the minimum surface area that I can add if I want to bring this tooling into my pipeline. So I've put an action into my GitHub Actions. I now need to send that out to my instance of
Yeah, you need to host Dependency-Track. Yeah, you need to host it. There is no option for it. I mean,
So go
as a vendor, yeah, or other vendors can, like, you can work with a vendor basically to do it for you, but you need, yes, at minimum, you need to host Dependency-Track.
And great documentation on the dependency tracker.
Dependency-Track is a terrific project. It exists they started in 2013, and they have a very interesting history. Like for first, I think, 5 or 6 years, they were like a handful of companies using them. And then it exploded. I think now it's like 10,000 organizations or something. Probably because of, you remember my scary slide about like solar winds, like, yeah. So after, so Log4j made, probably made this thing explode very, very much because people realized how poorly they are prepared for this kind of events. And I'm not working with AI machine learning for a while, but I used to work a lot in the early days, in the dinosaur era. I would say, no, I mean, not that dinosaur, but by modern standard, yes. But I looked a little bit in security, like I know a little bit about security of all those things. My expectation is a security problem related to AI machine learning models. They would really proliferate, like, and they may be bigger than things that we used to experience. Because even without security problems, people frequently have no idea why AI is returning some information it's returning. Like debugging AI is nearly impossible. There are very few people have understanding how it works. And even if they do, some of them are like mathematicians, they're not programmers, like a lot of problems. So it's very hard to debug AI on its own. So now imagine malicious actor injecting something into AI model. Like if you don't know about the event of injection, like if you never, if you weren't there, then even to understand that something that it was made like as a result of some malicious attack, is very, very difficult.
So that becomes a question of how do you know that you're using a poison model? And then downstream from that, how do you know that you have outputs that came from a poison model? So there's applications for new bombs all the way down there.
Everything started like as usual. And I remember saying the same thing on like previous meetup, like here 6 years ago, I think it was 2019, like not here, I mean in this group. Everything comes down to the chain of trust. So you are always establishing chain of trust. And SBOM and the whole transparency thing, it doesn't solve security, like nothing really solves security problem, but it helps you establish this chain of trust. So you have a vendor who validates that something is good, and then you have a next stage, and you have all those like hashes, digital signature, like BOM now may include digital signatures, for example, just to give you an idea how this is done. And so this is a mechanism how you can essentially establish this trust. So in Discord attack, they were making fake Python packages. Also in Node, in NPM.js world, there were examples where people were creating packages with names different by, say, 1 character from a very popular, so let's say a package has like 10 million downloads. They make the same with one character different, hoping that, let's say, 100 people will make a mistake. You know, the same thing happens on stock exchange. There is like some stock goes up, and then there is another one which looks exactly like this, but one letter different. And people don't realize, and by that, it goes up as well, just because it looks familiar. So here, it's the same. So with this thing, like if you have tooling like a dependency track, you would discover it very quickly. If you do if you do this check on every CI run. So this helps a lot, but fundamentally, you need to establish chain of trust, because there are problems which are not really solvable by this. Like there is a attack vector right now that, so open source world is under a lot of pressure now because of the state of economy, and attack vector is malicious actors try to gain some control of popular packages.
We saw that this week, right? We saw some of that this week.
Yeah. And so they try to, and those are valid packages, sort of. But again, if we have the whole tooling ecosystem working properly and common lifecycle enumeration integrated into that, we probably would be able to catch at least some of those, because we would see change in, say, maintainers. That's the biggest one. So the big company gets, let's say, company gets sold, or somebody takes over. So this kind of events potentially will become trackable.
It's amazing how much information
Yes.
that metadata, as you've been talking about, can really add some richness to how we're doing that risk assessment and have a better understanding of the software.
Exactly. Like
Garth, do we have any
not
questions
here.
from the internet? All right. How about from the room? Got a couple more.
Is there any similar solution if you're looking, let's say, at the company to say, I would have all this desktop software running? Is there a similar thing to say, well, that piece of desktop software uses this package that's now vulnerable within it? Or, because the examples we've seen are for web, Hydrogen, PM, Composer, etc. Is there something for desktop software that does the same?
Yeah.
So the question, specifically was, when it comes to desktop software, there's similar BOMs. I'll expand that to, I was working with a client who had some compliance requirements in the US around, like, is there any ZTE software or hardware or any Huawei software or hardware in this? Can you talk a little bit more about the breadth of these BOMs?
Yeah. Yeah, thank you very much for the question. Yeah, so the tooling to build SBOMs for software is very, very rich at the moment. And you can find tooling to build it for anything, pretty much. Now, if all you have is a binary, that may be an issue. Depends on the language. Like, say, Golang binaries, the tooling is very good to parse them. Let's say C++ binaries, I'm not sure. I didn't try myself, but I know it's more difficult. But if you have access to source code in any language, you may find these days very good tooling to build it pretty much as quickly as I showed during the demo. So one thing, so the point is that if you're a buyer of software, these days you should be able to ask your vendor to provide you with a valid BOM document. That's actually what it's coming to, the exchange system for this BOM documents. And another big thing which is expanding is references from one BOMs to another. So let's say I use a library that has like tons of dependencies and like underneath. So rather than listing all those dependencies in one huge BOM file I give to you, I can give you a reference to the BOM of that particular vendor. And then we need another layer of tooling, which would kind of merge all that and do you like a complete scan. I mean, again, we're not there yet, but this is where the vector of the industry is. That like you do your part, and then every vendor does their part. And now there are questions how we organize all that in the industry.
And so it sounds like to the question, if you are diligent about the software that you're procuring and installing, you should be able to maintain a library of your desktop software and can be able to mine that.
Yes,
for
yes. Any software right now, any software you are able. Okay, I'll say given source code, but vendors always have source code. But given source code, you would be able to produce BOMs for. I mean, I don't know about like exotic, like COBOL. I don't know if there are tools for that, Fortran. But any modern language, they're covered.
There's another question at the back.
Yeah, I have a question around SBOMs. I wanted to know currently what that looks like compared to SBOMs. Like, it seems like there isn't that much, like any standards, or from what I looked into, I couldn't find any standards compared to SBOMs. Do you know anything like any standards are willing to make ML bombs, or is that like
Any standards for?
Is that ML bombs?
Yeah, ML bombs.
Okay, good. Yeah. So the question was about ML bombs.
Yeah.
So CycloneDX. Yeah. So everything I showed on that slide, that's CycloneDX. So CycloneDX, ML bombs. Great question. I mean, I'm actually looking into this around nowish. So they have already types such as data. I may be wrong in exact terminology, but they like machine learning model data that already let you create machine learning bomb. So CycloneDX 1.6, the latest spec, already supports that. The problem is there are no automated tools, as far as I know, to do it. And there are no good samples. There is like a pull request or something I looked at recently with a sample, but it's incomplete, meaning there is still work going on. But they are going to have what they call like authoritative document, how they recommend creating those models. So to answer your question, this is very, very fresh subject. You can already do it. And so for Cyclone, there is, I don't have a link, but you can find, like, there is OWASP CycloneDX Slack. I think there is slightly under 3,000 people there. You can get into that. There is a person named Steve Springett, who is, I think he is vice president of OWASP. And he is like author of CycloneDX, like co-creator of, or creator of Dependency-Track. And he is a great person to talk to, and he is very usually open to questions. And generally, this community is very open to questions. So if you want, let's say, to volunteer, contribute, be involved, you can find them, and they'll help you navigate, especially if you have like a real-world problem related to this.
So the standard exists. It's, you know, ML bombs are standardized under CycloneDX. The tooling is still very fresh, and there's lots of opportunity to contribute if you want to be on the edge of helping that documentation come together.
Exactly.
So another question over here. So the questions around accuracy of the tooling, have you seen cases where it it's missing things? Like
Yeah.
how good? What's the coverage
Yeah.
when it comes to the tooling?
So great question. Yeah. So that's exactly what I showed on the demo. You saw there were two tools. One displayed licenses and the other did not. So this is happening everywhere. Also, sometimes tools would produce like older version of if we're talking CycloneDX, older versions of CycloneDX standard. Sometimes you would see invalid JSONs. I mean, not like everywhere. So I would say, and this is a great question also because so we make this, and great problem, we make this BOM document automatically. So how do we ensure this actually matches what we have? And this is an open problem to me as well, because you sort of have to trust to, like, the way I think most organizations approach it is you compare different tools, try to do like spot checks with the certain components, then see if some tools are missing, and then kind of I prefer to use where possible like OWASP CycloneDX project tools, because again, the established community organization stands behind them. Not to say they're perfect, but at least they're trying their best. But you have to, like, at least at this point, you have to trust this tool. But if you're a vendor, then essentially you're the one responsible. If you're giving this SBOM to the world, you would still be responsible to say that this is what it is. However, talking about compliance regulatory requirements, if you're like minimum, what they require is the top level dependencies. So top level dependencies, you can pretty much verify them manually. And then again, what I mentioned before, the vector of all this is you provide top level dependencies, and then you give reference to their SBOMs. And then if everybody is only providing their top level dependencies, then the problem becomes way, way more manageable. But we are not there yet.
So that sounds like there are absolutely quality questions when it comes to that accuracy.
Yes.
And there's a lot of responsibility. If you're going to be signing or attesting that this SBOM is accurate, you do want to have a good quality program to be sure that the BOMs are producing are accurate.
And don't get me wrong, tools are good. It's not like everything is terrible. And no, I'm just saying that mistakes may happen, and things that something is missed or something is not it should be, like those things may happen. But generally, like the checks that I was doing, I mean, they make sense. Also, it's good if you understand well your platform and your language. Let's say language like Node.js that have log files, they are much easier to assess because essentially everything is in your log file. Language like C are more difficult in this regard, C++, but still possible.
I think I saw two more questions on the floor. One in right over here. Go for it.
Okay. It looks to me as if you're creating a repository that's completely visible to everybody, showing all of the dependencies of all the vendors. Okay? So as an attacker, that looks really good to me. Hot soup. If I can find a way to attack log for GA16, then I will be able to attack, especially if I can keep it at 0 day as long as possible, I can go into 50,000, 50 million databases on the same day.
Pavel, talk about some of the trade-offs of publishing your SBOM.
No, it's a perfect question. I'll just repeat. So the question is, so if as a vendor I publish SBOM to the world, then if the world finds some compromised dependency in my list, then they know right away how to attack me. And it's I read, so that idea, I read about it. Okay, so what if the document lands on Vladimir Putin's desk? That's like, no, I don't remember the author, but that was basically the question. So the point is, you don't, like, if you're an open source developer, then actually there is no additional risk because you're already open source. So that we can agree on that, right? Then if you're a private vendor, that's different. But you don't, depending on the circumstance, you may or may not have to share everything with the world. But let's say if we take European regulation that are coming, they say that everybody who, like any app vendor, so if you publish anything on, let's say, Google Play Store or App Store or things like that, then you have to publish full SBOM, like top-level dependency SBOM for that, including, but I think they're still debating that. I'm not like that much an expert, and that's kind of what I heard, including what's happening on your server side. And I would say if you're not under these regulations, first of all, then you don't have to share it with everybody. So you share it with your clients who probably want to do security assessment or stuff like that anyway. And and you can sign NDAs and that kind of stuff. So this problem exists. There is nothing you can do. Let's put it, yeah.
I can just sort of add to that as I think about that, right? Which would be really great, was that it's one quiver in our tool set, one tool in our tool set of things to do. And clearly, hey, we cannot just have this one thing. Yes, SBOMs are great. We can use it to track and be alerted with dependency tracker of new releases and things like that. But as in the case of the 0 days, we need to have other things. We need to have threat intelligence. We need to have monitoring. We need to have alerting. We need to have
Exactly.
Defense in depth.
We have to do the defense in depth thing. So, as well as, if we're using open source packages, why aren't we looking at what's under the hood?
Yeah.
And if you are subject to the case where you do have to publish your SBOM, then make sure you're on top of the vulnerabilities of whatever you publish in your SBOM to the extent that you can be. The same way that if you're on the internet, a lot of what you're using is already discoverable, depending on how well you've managed to lock that down. So,
yeah, I agree. So essentially the question, in other words, the question is about security by obscurity, which is also like another thing that's discussed.
One more question from the floor. And we're coming up on time. We'll probably have time for one more. And if there's one from the internet, bring that one in. Go for it.
Yeah, I want to talk about security by obscurity. Does it make sense, like if you are a proprietary developer, you deliver these your binaries, closed source, but you deliver binaries to your clients, and everyone can see what's inside binary and can analyze that. So in the age when we have all these tools to analyze binaries and dissect what is inside and dependencies and so on and so forth, doesn't really matter whether it's open source or closed source.
The question from the floor is, as it's more and more possible to dissect and reverse engineer software, is security by obscurity? What's the line between open source and closed source at this point, as far as discoverability?
Yeah, I mean, that's. Thank you for a question. Like, response going to be opinionated. Like the case I'm thinking about is, let's say you're a vendor for a government or for a bank. There is, in that case, the likely would be, you would have an obligation to provide your bombs to that organization, say to a bank, but not, you don't have to publish it for everyone. And in this case, if I'm that vendor, I would prefer keep it this way, keep it constrained to only the organization that needs to see it. And I think it's perfectly fine. The idea of regulators, why you have to publish it to everybody, is because if I were to deduce the logic, is let's say you put the package on, let's say, App Store, everybody can download it, like anyone. And then they can try to break it in any way necessary, any way they want. So by hiding bill of materials in that case, you're really not protecting anyone. While by publishing it, you make it easier for general public to see all those vulnerabilities and if they exist. I think that's the rest. Also, it makes you more organized. So their idea is if you have to do it, then you care about those things. You have to care. You have to look at those scan results. You will see what they show. And essentially, this will make software more secure. I think, like, personally, I'm of that regarding security by obscurity, like, like the big argument against it, which you may know, the problem with it is if anybody, one person figures out what you're hiding, then it becomes very difficult for you to change your design and stuff like that. In this case, in terms of dependencies, vendors have to take certain, so for example, apart from obvious CVEs, you may establish a policy, for example, that no dependencies older than 6 months should be present in your tools. So things like that are possible, and they make you care about things. And these are like a good practice. This is how I would approach it. This is very opinionated subject, though, and it's not like there is a universal answer to how to deal with it.
Well, it's amazing to see how this space has evolved as things continue to get more complex. The tooling continues to keep up, and great to see so many OWASP projects at the heart of what we've pulled together here today. Pavel Shukman, thanks so much. One more time for Pavel.
Thank you.
And again, we wouldn't be here if it wasn't for the University of Ottawa, the IBM Cyber Range, Rewind for the pizza. Thank you so much. All of you, thanks for coming out. We'll be here again third Wednesday of next month, third Wednesday of every month, except when it's not. I got that right this time. I got it right this time. And hopefully it'll be a little bit warmer even the next time around. Great to see you. Housekeeping-wise, there are garbage cans, compost, and recycling at the back. If you have anything at your table, it would be great if you could help to make sure it winds up in the appropriate receptacle at the back. There is also still a bit more pizza. I don't want that one to go into the recycling or the compost, so make sure it goes into you. See you next month. Thank you.